Oh, hey, you again. So I was eating these Apple Jacks, and I was thinking, they taste good, but they don't taste too much like a real apple. They certainly don't look like an apple or feel smooth like an apple, and they're dry, unlike an apple. And I think about why matter looks, feels, tastes, acts differently is because even if they might be of the same elements, those elements could be arranged differently, and even though these are both made up of carbon, hydrogen, and oxygen, this has some trace elements, that means elements in tinier amounts, that make the apple look so different than Apple Jacks. So today, you're going to do two things. The first thing you need to know how to do is identify a mystery atom. Let's take a look at this one, for example. Oops. I need to know what atom this is. Well, first, what's the most important subatomic particle again? Oh yeah, the protons. I bet if I just count the protons, I'll know what atom this is. So protons are the positively charged ones, and I see 1, 2, 3, 4 positively charged protons. So the way to identify a mystery atom, first count the number of protons, in this case it was 4, and then look at your periodic table. I know that this is now beryllium. Make sure you know how to do it, it's on your Prove It today. The majority of your day today will be looking at different cereals and deciding why they all look different, feel different, and identifying what those physical properties are. So you're going to open up your notebook and you're going to write your testable question, which we know always starts in the form, how does blank affect blank? So we're going to go ahead and write that down. The first thing you do in an experiment is decide what you're changing or comparing. That's your independent variable, and we're going to compare the cereal type, so we're going to write that there. How does the cereal type? Because we know that's what we're comparing. We're going to compare it to see what though? Well, we're going to look at all the physical properties. Physical properties mean we don't have to change the cereal, we're just going to make some observations. So our dependent variable is physical properties. You should be writing this in your blank too. The only other thing I wanted to show you is how to set up your table and how to measure some of these properties using your cereal. The first thing we always have in our data table is our independent variable, or the thing we're comparing. In this case, it's the cereal type. You're going to flip your notebook over so that your table runs like this. So I'm actually going to show you the first header, like this. Okay, so flip your notebook over. The first header is cereal type. The next header is texture. You're just going to write how it feels. The next one is density, and that's a greater than or less than sign, 1 gram per milliliter. So you're going to write greater than or less than 1g/ml, because gram per milliliter. You're going to compare the density of your cereal relative to water. So for this part, all you're going to do is take your sample and drop it in to your water. If it floats, it's less than 1, and if it sinks, it's greater than 1. The next property you're going to observe is your color and shape. And the last one we're going to do is magnetism. And as you can see, the unit is percent. I have units on 2 of my headers, so I know that those are quantitative. To see magnetism as a percent, you are going to have to take the rest of your samples, that's why we're doing it last, and you're going to crush it up into a fine powder. After you're done crushing, you're going to take your bar magnet and run it along and guess what percent of the particles were made of iron. This could be anywhere from 0 to 100%. I hope you enjoy observing these different physical properties, and tomorrow we'll actually explain why they're physical properties and not chemical, and what some other physical properties we might observe in other types of matter. All right, enjoy your lab.